Ladies and gentlemen, thank you very much for joining this second podcast. Today we have Miss Mehrun Nisa with us, Miss Kamran Nisa, and also Miss Thania Saif. And we will be talking about a very important topic, and that is that our language models are only for text processing, or they can do some domain specific tasks as well. So we are going to ask this question from our guest speakers, that what they think, up to which extent a language model is capable of doing the domain specific thing. And it is very interesting to see that the guest speakers have chosen a cybersecurity field topic, that is malware analysis. So, out of the box, some topic that is really difficult to perform even by the reverse engineers, and they think that a language model can do it or cannot do it. Okay, so today debate is about all that process, all that techniques that can be used, and whether it is successful or whether it is not successful. As well as they will also compare the open source one and the chat GPT one efforts as well. So first of all, I would like to ask this question from Mr. Hania Saif. What you think about this whole paradigm? Why you think that language models are not only limited to text processing and they can do the malware analysis as well? What is your point of view about that, Mr. Hania?
Okay, sir. As we already discussed in that previous lecture regarding that reverse engineering topic, that ChatGPT is unable to keep security or data privacy of our content that we try to share with it. Like we try to share our malware secret type of content. Malware contains some secret type of content in itself. When we try to share it to a public platform, then there is high security breach chances available there. But then what will be the alternative against such platform? For that purpose, we try to counter it through open source LLMs. In open source LLMs, we actually try to apply or implement these type of malwares or study about these type of malwares through our own system. Like we want to analyze what kind of malware it really is, what kind of obfuscation or encryption type of techniques are implemented in this whole scenario. Like we have to understand the impact and the response and analysis of the complete malware that is unable to perform through any kind of online or publicly available platform. As we know, ChatGPT is able to perform the analysis against any kind of malware, any kind of discussion we will discuss through it. But the main impact available there, or the main emergency situation occurs there, is the breach of our private security. Like whenever we try to share a private malware or shared malware or content that we try to capture through any online platform, that is unable to that at that point ChatGPT is unable to maintain the security of that particular malware. Like that is a third party platform. Like it will share our content to another platform to keep it safe. But that is not safe. That is not safe at all. Like if it will share our content with third party, there will 100% chances to breach of our company security, of our main security analysis and content. Each and everything will be depend on this specific security content. For that purpose, we will try to explore into the lecture regarding the open source LLM, that whenever we try to keep the security of our private malware or asset, what we need to do or what we have to do to keep its security, as well as we also want to analyze its security.
Yes, Ataniat, first of all, I think we should just introduce this topic to the audience first. Talking about malware analysis, why we have chosen malware analysis for this testing purpose. So malware analysis is a topic which is very hard for reverse engineers as well. And here we are basically testing ChatGPT or large language model specifically for different types of data. So we have different kinds of data here. We have images, we have text data, we have audio files. But basically focusing only on the text data, we have a lot of variety here. Like ChatGPT is basically meant to understand the text form of data like natural language. But what about the text that is not actually natural language? So talking about that, we have a very good example of malware static analysis. We have chose it because of its basically complexity and variety of data, different types of data here. So in static malware analysis, we have codes, assembly languages code. So we have an executable binary, and we basically convert this binary to basically we decompile it to an assembly language code. So that assembly language code is not understandable to anyone except the reverse engineer, because assembly language is a complex language. It's not like a high level language. So it's totally in numeric form or alphanumeric form, and it is very hard to understand it. So that's why we have chosen, because we want to test what the capabilities of LLMs, that what to what extent they basically want to perform. Another thing is that I want to highlight here, as here we are facing many kind of issues with reverse engineers, because sorry, with not with reverse engineers, with static malware analysis specifically, because we have tried to basically automate this process of static malware analysis through AI, because we want to do these manual tasks with AI all the time. And we were doing that in the past, and we have a whole seminar regarding it, regarding the static malware analysis and the complexities we face, and the realities, the myths and realities of it. So we have a whole seminar. If you want to watch, you can definitely, we would recommend to have a look at it, because you will understand the complexities we have faced, the issues we have faced while doing that. And there are two types of malware analysis. First is the ones that are basically they are telling us that the whole file is malicious or not, and the other is function level analysis, where they are telling us that what function is actually malicious and what functions are not malicious. So in this scenario, we have faced a lot of issues with static malware analysis with AI, because in AI, we all know that to process a data to a neural network, we want to basically convert it to numeric form. So because ASM is already in numeric form, but we want, it is not a unique form of numeric data. It is not completely in numeric form, but it is in alphanumeric form, and it is very difficult for an neural network to basically connect the patterns, because there are so little details in it. So we have faced a lot of issues in pre-processing, and to be very honest, I have also worked in static malware analysis with AI techniques, and we have used very traditional techniques there. And the whole process of pre-processing was actually 80% of the whole project. That means that we are on the whole project of that static malware analysis with AI. We are only like 80% of the time we are only doing pre-processing. So that was the main concern that we faced. And also with LLMs, talking about LLMs. So we have seen that they have processing powers of large data. And here we are basically going to test it, that if because whenever we are doing static malware analysis, we want to clear one thing about LLMs. The one thing is that whenever we are talking about a code or analysis, we are basically focusing on if that LLM is able to understand that language or not. So basically, we have seen a lot of LLMs that are specifically for code, and even for ChatGPT, a lot of people are talking about that he can generate a lot of code, and very nice codes as well, that are basically executable, and they have done wonders. But the problem here we are focusing is that assembly language is a very tough language, and we want LLMs to basically understand it. So the first step is for any analysis, we have we have to determine that if the LLM is able to understand assembly language or not. So we have already done that, and Ms. Tehniyat has a lot of articles that she want to share, and also the articles that we have shared in the previous podcast as well. So we talked about, basically we talked about that how people are using chat gpt. So we also want to test that if chat gpt is able to do all that stuff, can an open source llm do that? And I want to highlight one more thing here, is that open source llm is deployed on premises, or we can call it we can deploy it on a cloud and basically access it from the api, because we don't have that much hardware. So we are basically using a platform called Petals, and Ms. Tanyat will basically describe about that. So over to you, Ms. Tanyat.
Thank you so much. Okay, so basically, as we discussed on already basis that we are going to perform malware analysis. Like in malware analysis, we have to do some reverse engineering steps. Like we have to analyze the actual file against that malware that is basically available in exe format. So before moving forward, we have to analyze that is open source LLM able to completely perform the reverse engineering steps, or it is able to perform some variations, some step, or analyze some at some extent, like ChatGPT 2 do that as well. Like a reverse engineer try to decompile the binary file, disassemble the binary file, as well as perform some other steps to analyze the exact malware code behind that exe file as well. So we are not able to we are unable to perform all of these steps through any kind of open source platforms or chat gpt or any platforms that is particularly available, as these are only performed through the help of tools. Like there are multiple scenarios or multiple tools available for that purpose as well. Like if we want to decompile or disassemble some file from exe to assembly language code or any other context of code, that will entirely depend on the nature of that particular malware which we try to test. That after the decompilation, we will move towards the analysis of that particular file. Like we are able to get some malware analysis in terms of assembly language code, as well as some .NET binaries, and some other kind of malwares also available through multiple platforms. So we will move towards the analysis process, as how we will perform the analysis and what kind of discussion will be performed will be discussed in this matter of malware analysis. Let me share my screen first. Okay, so as I already discussed, that we are going to study about some malware topic or malware content, that we will try to question through which we will try to question our queries against that particular online platform, that is open source LLM. Also we have some chat gpt context regarding as well, where we try to discuss some queries, like we pass some queries to the open source LLMs, as well as we will pass these type of queries to the chat gpt. Like we have to analyze that which platform complete our query responses. Like if we pass our queries to chat gpt, is it able to analyze the context of that binary file, of that exe file, of that particular assembly language code .sm file, asm file, and it will able to pass the response, a particular response to ourselves. Like starting from that
Tahniyat,
dot. Yes.
sorry for interrupting you. Basically, can you tell the parameters of that model we are testing right now? Because I know that this is not a compare like good compared to Chat GPT. So we all should know that how it is compared to Chat GPT in parameters as well. So how much
Okay,
like
sure.
parameter model you are testing?
Like we are testing about almost 70 billion parameters. Like we are testing open source LLM, that is llama 2 platform, that we try to test, and that where we try to test and analyze our security of contents as well. Actually I have to show something to you people as well, like petals platform, that is, wait a second. as in previous lectures and in today lecture as well, where we try to discuss the open source platform. And we have to show you some platforms that is openly available or publicly available for the testing purpose, that we try to test, that we try to where we try to analyze, and where we try to pass our security content and try to capture some response through it. As we all knew that we have ChatGPT platform with a good interface as well, where we try to pass some questions and it will generate some queries or response against that particular question of ours. Similar way, we have some platform that is known as Petal. Petal is an open source platform where we have multiple type of large language models. That is Falcon with 180 billion parameters, Llama 2 with 70 billion parameters, and Stable Beluga with 70 billion as well. Also, we have some other variants of Llama model and Bloom model as well, where we try to pass our query and our content as well. Like we try to pass some assembly language code, some Python, some Java type of code to it. Also, we try to pass our queries, like we want what we try to analyze, what we want to perform against that particular code as well. Like we want to analyze the function level analysis, the API calls, the maliciousness, the endurance of that particular malware as well. Through this whole type of content, we will try to analyze the whole malware maliciousness and content in between itself. Uh, Here we will try to pass some queries like some code as well, that I will show you here. Like
Miss
as we
Tehneed,
discussed.
sorry to interrupt you, Tehneed, but I have a question here. Uh, Before
Yes.
starting before going into the practical implementation in details, I have a question here. Basically, when we analyze malware or any kind of malicious stuff from the ChatGPT or from any open source model you are talking about, so people usually try it on a very simple and short piece of sample, like which the model can accept as an input. But on other hand, as a malware analyst, if we think about it, we do not deal with such simplest samples. We have definitely complex and long files. So what is the behavior against these real world scenarios in context of both ChatGPT as well as open source LLM? Any one of them is able to interpret this kind of complex type of malware or not?
Okay. So that's a good question. Actually, we try to pass some limited content to the open source LLMs for now as well, as they have some size limitation on their platform. Like whenever we try to pass some query or some malware analysis file to the ChatGPT platform, it has some limited content. It has no limitation. Like we are able to pass almost 1500 parameters, 1500 tokenized based files, and some other length or totally depends upon the topic we try to analyze, totally depends upon the malware file we try to analyze. But at the same time, these online platforms that are publicly available for LLM for testing purpose as well, they have some limitation issue. Like they only get some limited content file from ourselves. Like we can pass some 3 to 5 KB or maximum amount of 9 KB file to that particular platform. If we want to analyze our malware or context against these type of malware type, like these type of malware only exist through our through .NET binaries, or some limited contents exist in this type of size malwares. As we all know that malware is much massive or big in size, that we try to analyze. So for that purpose, we have to divide the whole malware code into chunks. Like we have to divide the whole ASM code into chunks. And whenever we try to pass that chunks to the open source LLM for analysis, for function level analysis, it will remove the main asset. Like we have to choose some platform where we try to divide, where we try to utilize, which we try to utilize for dividing purpose. Like we have to divide the whole code into similar type of chunks. Like there will be no existence for any gap. Like we have to pass the whole content, the whole code to any platform even it is ChatGPT or even it is open source LLMs. It has to analyze each and every context of that whole malware and then try to respond against our platform. For now, these open source LLMs have a big limitation, that is size, as these are only as these are
Even
only
I think this limitation of size is with ChatGPT as well, because LLMs can never, like I have not seen any LLM that can process a very large amount of file. Like binary files are, if I'm basically highlighting this, then binary files are basically very big. They are gigantic, very big. So this is a very a prominent limitation of LLMs. Specifically talking about petals as well. Here we like ChatGPT can basically analyze a file up to 1500 lines, but here we are dealing with petals, which is basically providing us a platform where an open source LLM is made public to users, and we can basically chat with it. So it's itself a very big contribution from the people of that made petals and llama, and they made these open source LLMs for us to test public. So we have this limitation of basically size, and we will discuss about it, that we will discuss in the upcoming topics as well, that why this limitation can affect our analysis, because assembly language files are very big in size, and also compared to any other things, for example, when we are talking about obfuscation, in obfuscation we cannot make this code short, because the whole purpose of the code will vanish if we make the code short or something else. So here we have basically approached a strategy. So our strategy is, if these LLMs can analyze a short code, it can do the long code as well, because all of these things is basically depends on the hardware, like how much it can process, what are the long and short term dependencies, and we will talk about in details in the upcoming podcast as well, and our whole basically experience as well. So
So
for now we are testing the short binaries.
Meher, if we compare the ChatGPT, is not it low parameter model, but we cannot expect the ChatGPT like behavior, is not it?
Yes, exactly, definitely, because we are testing a 70 billion model and ChatGPT is 175 billion. So we cannot expect a ChatGPT like behavior from a Llama model. But I want to highlight one thing more, that ChatGPT is very well crafted. It is very, very well fine-tuned as well. It has used RHLF techniques, and it has been training for like fine-tuned for, I guess, 3 to 6 months. So we cannot compare these models to ChatGPT, but depending on the
We
fact.
sorry to cut you. We cannot compare, but actually, from your this point, I want to take discussion to a more advanced level of malware analysis, which is obfuscated binaries,
Yes,
right?
sir.
So, where the open source models are able to de-obfuscate a malicious binary, are they capable? If not, what exactly will be needed in the fine tuning? And keeping in view the point of RHLF that you were mentioning for fine tuning of 3 months or 6 months of effort, you see, like having a 6 month of effort on an open source model for reverse engineering, like in 6 months, if you will be having uh, an open source LLM, which will be domain specific for malware analysis, which will be kind of replacement for reverse engineer up to some extent. Okay. So this 6 months is nothing actually. To me, this is not something that that we think that this is much more time. No, it's not that much time, because 6 months is a usual time. But can
Yes,
we do
exactly.
that? Can we specifically talk about that? How obfuscated binaries uh, can be actually de-obfuscated or can be analyzed by a language model? What
Uh,
things will be needed for that? Yeah, Miss Meher.
Sir, basically, we have talked about it with examples as well in the document as well. But I want to highlight one thing here is that the LLMs that we are seeing right now are general purpose models, and they are trained on a lot of things. Like they are meant to do a lot of things. It's like similar to someone that can do a lot of things, but it is not specialized in one task. So it is this with a similar effect here, and we cannot expect chat gpt like platforms or llms to do all the things very efficiently and very in a specialized way. So like a human being, we have experts for different things. So a human brain can store can be specialized in 1 2 3 domains, and then they know a little bit about everything. So when we are talking about llm specifically, so chat gpt and this petals as well, it can write a code, it can write poem, it can write a lot of different things. So we cannot expect that model to be specialized in a task that is meant to be general purpose for him. So it can analyze it, but not that efficiently. But here we are just testing that if llm can analyze it or not, if llm can do that task or not. If it can do to some extent, then we can talk about that how to make it domain specific. And coming back to your question about obfuscation, we will discuss about it, that what limitations it has in obfuscation as well. So when we are doing the domain specific model, we will keep this thing in mind that we are doing it for subli language, and we have to give attention with transformer attention model phenomena with to obfuscation as well. So we will give a lot of obfuscated examples to in fine tuning. So this model is not meant to do it very efficiently, but that model is given the training data to do it efficiently. So in the examples that we have created, that Tahniyat will basically present, she will basically talk about a real world malware as well that a reverse engineer gave us and asked us questions about, and to which extent it basically answered the questions. So when we will understand that, we will get to know that these llms, these general purpose llm can do that, that if these general purpose llms can do that, then we can improve it if it makes sense.
Actually, whenever we try to discuss about this matter, we are saying that we try to compare our result or analysis with ChatGPT. We are not comparing our result or any kind of context with ChatGPT. We are trying to provide an alternative platform. We are trying to discuss about an alternative platform that will also do similar type of tasks that are performed through ChatGPT. As ChatGPT is able to analyze the malware, is able to perform all of these steps whenever we want to perform as well. Similar way, these type of open source LLMs with low parameter as well, as we know that these are 70 billion maximum to 180 billion, 150 billion, or 7 billion as well, 3 billion. They are totally depend upon the nature of that particular open source LLM. It's entirely an alternative platform for ChatGPT. It is not a competition for now as well, as they require some fine tuning as well in their process. These are only working on currently on the basis of pre-processing. Like whenever we try to apply some context or provide some context to that particular platform, that is open source LLM, as we already discussed, that is Petals, that is publicly available with some kind of open source LLMs for testing purpose. They are just pre-trained and pre-processed for that moment. They're not fine-tuned at all. Like whenever we try to pass some obfuscation file or some deeply encrypted file to that particular platform as well, it is unable to decompile that as well. It is unable to understand the main context, main query, and main assumption available against that particular malware as well. But on the other hand, if we try to pass that obfuscated file or that highly encrypted file to ChatGPT, also ChatGPT is unable to crack the security of that file. Even if it able to crack the security of that particular obfuscated file, it is unable to share
What do
that
you mean by
security responses with
cracking
us.
the security of that file? Are you saying about obfuscation, deobfuscation case, or what actually?
Actually, sir, I am talking about obfuscation and de-obfuscation case, as ChatGPT
Okay.
is an AI
Okay. So
assistant.
you are actually calling it as an obfuscation and deobfuscation, right?
Yes, sir.
Or cracking the security. Okay. Go ahead. Go ahead.
Okay. As I am discussing that ChatGPT is also unable to de-obfuscate any kind of encrypted and obfuscated file. Like it also has some limitation. As an AI assistant, it is unable to provide the inner and security responses like malicious content. Whenever we try to pass some malicious content to ChatGPT, it will not able to provide exact response. Like we are asking that is our context malicious, is our file malicious, or is that malware which we try to analyze or give to you, is it malicious or not? In simple words, it is unable, ChatGPT is unable to respond that against that particular platform. It is able to perform, but there are some
No, but
security
actually,
limitations.
that is fine. You see, so are we coming to a conclusion that both open source models and the chat GPT, they are not capable of having a very fine cracking of the tactics that are being employed by the hacker in the form of obfuscation and many other things, right? Let's talk about the solution. Can now how can we use RHLF and other techniques to really make it domain specific? Do you think like this is doable? What do you think about it, Miss Kamran Nisa, Miss Mehran Nisa? Like, is it doable that we make it so domain specific that it it actually kind of replacement for a reverse engineer?
Basically, when we are talking about replacement of a reverse engineer, or I will also talk about replacement of the tools that are used by the reverse engineer as well. Like IDA Pro is used by reverse engineer to decompile the binary or to basically analyze the specific a portion of the binary for function level analysis. Basically, whenever we are talking about that tools and a reverse engineer is very basically experienced, and it can basically guess by just by looking at a file, and he is professional in that. So in that scenario, there is a long road to go with LLMs. But when talking about replacing the tools that we have used with advanced tools that are basically giving us the opportunity to basically analyze it like a human, or analyze it like if I talk about myself, I will give you an example here. I know what is assembly language, and I can understand it a little bit, but I'm not a professional in it. Like I'm not a professional reverse engineer. When a reverse engineer gave us a code, or when I picked assembly language code from a website, and I basically pass it to the chat gpt or petals llms, I was basically a layman. I did not know anything about LLMs and what that malware file is doing. So when we pass that content to it, and it basically answered me like a human or in a natural language processing task. Like for example, if I talk about like some questions that Tahniyat will explain as well, that we have usually a reverse engineer would ask from himself about a binary, that if like what are how that binary is malicious, or what are the APIs used, or such kind of questions. We have over 50 questions that we asked and these LLMs. So when we are talking about that, uh, we are basically layman's at that. LLM is basically telling us everything about those binary files. So it's like giving that LLM a code and basically making him analyze that. So if that LLM is able to understand assembly language very efficiently, then it can basically do the job of a reverse engineer as well, because everything is in the assembly language. There is nothing that is out of it, that except dynamic analysis,
Saying
obviously.
that basically, if an LLM has some knowledge about assembly language and you want to update its knowledge more in assembly language with few other aspects that he's not trained with actually, so how will you do that? Through RHLF, through fine tuning, how you are going to achieve that. Because if we are capable of this thing, this mean exactly we can do anything. I mean, I'm taking back again the thing that you actually you pointed out, that ChatGPT is very, very well trained uh, through fine tuning and RHLF, right? So
Yes,
how
exactly.
can we use that for that specific purpose? Actually, that's what my point is.
When we are talking about domain specific LLMs and a domain specific thing like assembly language, we don't need to do like RHLF to it, because RHLF is supposed to basically behave like a person or a good chatbot with people, because ChatGPT used it. So it's not like that it's necessary for us as well. But the thing here is that ChatGPT or any LLM is trained on the data of the whole internet, or almost the whole internet. What kind of information or what kind of data we have with assembly language? If we have kind of 5% of data, from 100% we have 5% of data in assembly language and static malware analysis, which is I'm talking like 5% even very a large amount of data. But if it is trained on it is basically encountered 5% data of static malware analysis, and it can behave like that. So what we want to do, we want to increase that data. Basically, we what we are doing here is that we have a general purpose model which is, let's say, 30 billion, and then we will make it uh, through fine tuning. We basically extend its knowledge into a more specialized task, which is static analysis. So what we want to do, we want to uh, basically introduce more data and give that model more examples. So we want a lot of data here for making a model domain specific. And also we want to very craftily give the attention for obfuscation as well, like the tasks that are very complicated, and we faced a lot of struggles when we were doing that those tasks with the general purpose model. So we will pick those tasks like obfuscation, let's say, and or basically detecting a malicious activity. So these tasks are very like that needs attention, and we face a lot of struggles with general purpose models. So what we will do, we will basically introduce and show the model a lot of examples to make him learn more. So that's what we are going to do with domain specific models, so that we have 80% knowledge of a domain, a specialized domain, and 20% of other tasks. So we are not specializing this model to any other task, but to assembly language or static malware analysis.
Actually, we have to show the audience regarding the context we are discussing right now, as what how we are performing the malware analysis, through which context we are trying to do it. Also, with what kind of prompt analysis we are perform against these kind of malwares. Let
Yes,
me share my
exactly.
screen. Basic kind of malware type of code to the open source LLMs like Petals. We have to analyze the the security, the function level analysis, as well as we try to analyze the API calls, if there any malicious content available there or not. We also try to discuss here that what kind of at what level the maliciousness exists against that particular platform, or is that Petals platform able to crack that malicious content, or able to understand the main content and asset of the particular malware which we try to it as through ASM file. Like whenever we talk about ASM file, we will pass it to the Petals platform. Here we as we try to pass some open source as we try to pass some malicious malware and content like a virus code to that particular platform, that is Petals, and we try to question that platform, is it malicious or not. If it is malicious, then tell me what kind of maliciousness exists there, at what kind of level is it malicious, or can you explain the main asset, main context behind that code or virus. Also try to tell me in short what kind of platform will be affected through this kind of malware, what will be abusing platform, or anything regarding the maliciousness verification and each and everything. For that purpose, we try to pass some malicious code, malware code that is almost 3 KB in size, in total size, to that Petals platform, and it try to analyze that particular code with deep analysis and try to pass some response in that against that particular code. It also it tells us that code is particularly malicious or virus code. Also, it tells us that what kind of virus it contains in itself. Also, what which platform will be affected through that particular malicious code context. Actually, this information is pretty much needed against any kind of analysis or any kind of malicious malware analysis. Like we have to analyze first what as our malware is malicious or not.
Ladies, I want to actually really focus on this thing basically. Okay, that how can we have RHLF of a model, and how can we actually really train it in a way that model will be suitable for any specialized purpose, and model is capable of doing some general things. This means the model has a knowledge, like it is not totally blank, right? And for special thing, how that more specialization will be achieved through fine tuning, core fine tuning. What are the steps, how these things are done? This way, like we can compare open source models and the closed source models basically. Okay, and also I want to mention the shortness of time as well for this podcast. We should have a second version of this podcast where we talk about more about all the things that I'm mentioning now, like how this will be achieved. Uh, what do you think about this, Miss Mehranisa?
Yes, sir, I agree. Basically, there are a lot of things that we have tested with a static malware analysis, and another podcast is coming about vulnerability detection as well. So it is very important, and I have described in detail as well about domain, how to make that domain specific. So the main, so the in very simple words, we are basically just giving more data to the LLM, because LLM is basically exposed to
What type,
a little
what type
data.
of more, what type of more data you want to give? More obfuscated data to the LLM
More
to have it
examples,
fine
more,
tuned?
yes, exactly, more examples, because in the
Like,
internet we have a little.
okay, more examples of obfuscated data, right?
Yes, exactly. And it would
Okay.
not be like one or two examples. We would give like a lot of data, like a fine-tuned data is around, I guess, minimum is 5,000 tokens, I guess, and it is a less tokens is not that much. So we are going to give that model a lot of examples of assembly language code, real world examples, and how to behave as well, like how to behave, because most of the time Tahniyat basically told us about Petals. Petals is basically just a platform that basically make open source LLMs. We are basically it is basically making the open source LLM to basically chat with us. So we don't have anything else. We have a Together AI platform that can do that. So we wanted to test a very good billion model, but due to hardware basically limitations, we could not do that. So because it's very hard for us to basically load even a 7 billion model in collab free version, so it is not an easy task, and loading a 70 billion model, we cannot even think about that. So that's why we chose Petal, because it basically giving us this opportunity about using that open source and testing those open source models. And it is basically not fine tuned on a specific task, but basically it is fine tuned on instruction following. Instruction following, like you can watch the course as well, where we have discussed about instruction fine tuning and fine tuning techniques as well. That specific LLM is going to is was doing that. So what we are going to do to make it domain specific is fine tune it on the tasks that we are going to basically that we want that LLM, that domain specific LLM to do. So for example, if we want to want that model to specialized in reverse engineering. So, or static malware analysis. So what it going to do is that he is able to do everything that is a reverse engineer would do with a binary. So what are the necessary steps? So it will ask questions like 50 or 60 kind of questions to analyze the binary. So we will give those questions with answers in the training set, as well as we will going to expose that model to a lot of obfuscated data. Like we will going to tell that model that this is obfuscation and how to deal with that. So we are basically training that model and telling that model everything about how to analyze the binary. So that's how we are making those models domain specific.
Sorry to interrupt you, Madhunisa.
These
Actually,
yeah, yeah, go ahead.
we have to discuss the pricing and each and everything regarding the context of fine tuning as well. Whenever we try
Yes,
to
exactly.
discuss the details about fine tuning, we have to understand the cost and privacy against that particular purpose of fine tuning. Like, can
Yeah,
you
yeah, yeah. If you
elaborate
go
what
on
kind of costs?
together.ai, yeah, yeah. If you go on together.ai or even OpenAI for fine tuning any model, GPT-3 for anything. So yes, and of course, privacy is also a big thing as well. So how to make that computation safe and also very cheap? This is also something question of the hour. So I think I'm getting now the objectives of this podcast that we have set, and I want to have version 2 of this podcast as well. Okay, and a second podcast on the on the same thing where we do research and come up with the extent that a problem is the security, as Daniel mentioned, security of the malware is cracked or not, or obfuscated, deobfuscated, and we should do some more work on it and come up with some examples. Pricing thing as well that Daniel has mentioned, and should have a follow up on this podcast, and this will really make it very good, how can we make a domain specific model. So if you all agree with that, I'm going to off this podcast, and then we can have a second version of it. Do you all agree on that?
Yes, sir,
Sure,
sure.
sir, we will do that.
Yes, sir.
Okay, sure. So thank you very much, everyone, for this very great debate today. Let's have then a follow up on this podcast, inshallah, very soon. Thank you. Thank you.
Sure,